Welcome to the live stream. Mustafa, Max, hello. Early birds in chat. It's nice to see. Today's all about context mapping and domain-driven design. I hope you have some domain-driven design enthusiasts in chat, because we're going to tackle the part of the book that nobody usually reads. I have to admit, when I first went through the book, the Blue Book by Eric Evans. Hello, Monsif. The first time when I went through the book, I just wanted to get to the tactical parts, which we did last week, by the way, with John Gallagher's help. We had a 2-hour session. Today is going to be strictly 1 hour because I have the book club right after this. So today is going to be quite practical. We're going to do the context mapping part of the book. It is part of the book. It is in the meaning of the word context. We are talking about bounded context. So this is all still domain-driven design. But there are some aspects of it that align really well with microservices and align really well with domain-centric architectures. Domain-centric can be clean architecture. Domain-centric can be hexagonal architecture. It can be layered architecture, vertical slice architecture, right? So any kind of multi-layer architecture paradigm that has the domain, the business domain, as its center, works very well with all domain-driven design practices, especially with context mapping. So since you're here in chat and maybe you can participate live, I would invite you to maybe just think about it for now. If you have an idea, what is context mapping all about? If I start a new project and we're doing whatever we're doing, Scrum, Agile, our own system, Lean, XP, we're starting off a new project, we have a meeting. Why would we context map? When does context mapping matter? What do we want to figure out? That is my main question to you, and that is the question that we will answer together. So if you have any ideas, if you have some insights, it's okay if you give the wrong answer. It's okay if you give the right answer. As far as we're concerned, we're all learning. There is no right or wrong, especially with the book. It's very exploratory. So don't worry about trying to get it right. Just try to make progress in your level of understanding. There we go. Let's see. Very good. Very nice chat participation. Thank you. I will, in the meantime, my delay, I do have a 10-second delay, I believe, to LinkedIn chat. So I will always give it a little bit of extra time so that you guys can catch up. And now let me share my screen. Let me get the correct screen, because we have a nice little open source project here that will help us with this. So this is, can you see it? We need to increase this a little bit. Good. Yeah, that's it. So this is a little project that was prepared by the DDD crew. And Vlad Kononov's book, What is Domain-Driven Design About, also goes into this, into a very good level of detail. So the links are, I'm aware that I don't think my messages paste over to LinkedIn, so I will paste it manually. This is something we're talking about. So this is the context map GitHub page. And then we'll have a second link later on, and that will be a mention of what is domain-driven design about by Vlad Kononov. Kononov, yes, Vladik, Vladik Kononov. I will add them to chat earlier than last time, so you guys can follow through and check what's going on. Awesome. Okay. So if nobody's brave enough to voice an opinion, let's start with the important parts of context mapping. First of all, context mapping ties in together very well with the domain-driven design concept of ubiquitous language. If you've ever done any kind of spec or architecture spec, or even just database entity relationship diagram or an UML diagram, you will quickly notice that when you created the perfect spec, you created the perfect schema for how something should work, and then you realize that on a meeting, somebody isn't using the word they're supposed to. You have like a payment intent in your database and a transaction, and the product owner or a subject matter expert uses the word transaction to mean what you meant with payment intent, right? And that can be very frustrating. It's like, no, we use that word for something else. So it's that element of we use that word but for something else. That's what ubiquitous language is about. I'm very sorry. I will try to pronounce your name. I'm very sorry if I butcher it. Abdesata? Is it a sh? Abdeshata? Or is it just Klai? Is that your surname at the beginning? Either way, hello. I'm sorry. I'm not familiar with that. Oh, let's connect, and maybe I need to learn something. There we go. We're talking about context, specifically bounded contexts, and how context mapping helps us navigate a complex domain. Mohammed, hello. The idea that we're trying to target here with context mapping is that we're trying to understand how we use certain words. If I carry you over here to Excalibur real quick, right? There's this concept of imagine. Oh, not far enough. Imagine you're at a normal grocery store, right? We're at a grocery store, and I have a basket of apples. Right? Is it readable? Yes, it's readable. Awesome. I have a basket of apples. So Dennis, hello. That's me. Boom. I am a customer. A blue customer. Then you have an employee. Okay, an employee. Make the employee blue, red. Let's make the employee red. Let's make them purple. There we go. Cool. Employee, customer. Let's imagine that there's no digital stuff going on here. I just want to pay them money. Money. Right? Which is cash. I want to buy apples. And the employee gets a salary, right? So the more apples I buy, the higher their salary. That's how it works, right? Right? No? Oh, you mean they're like the money I paid needs to be split up into multiple chunks? Like somebody else is getting paid as well? Vendors? Suppliers also need to be paid? Hang on. Whoa, wait. So I'm paying them something, then I'm paying them something. This is now, even though it has a certain balance to it, this is now starting to get asymmetric. And then you add taxes to this, and then you add fees to this, and operational costs, and fixed costs, and amortization costs, and maybe you have a loan, so you have a completely different financial system. And you can quickly see how things get very complicated very quickly, because if I try to model the system now, not even digitally, just model the system, just put the human flow of information in this case being money, onto a whiteboard, I would be hard pressed to say, well, wait, this is a transaction, right? And this is also a transaction. And this is wait, okay. And sometimes the employee buys something, and that's also a transaction, but then is it cheaper for them? Right? And this is essentially what domain-driven design is helping us solve. And I'll remove this, just we don't need that level of detail. I'll just remove this. The immediate idea here regarding context is that this part here, just by the words that we use, just the fact that here money has something to do with transactions, like there's some kind of invoice, we're buying something, like we're paying for the purchase. There seems to be a context. And then when there's money involved in another context, this seems to be involved with something completely different. Because this left side, the pink one, seems to be involved, when the employee gets their money, that's a paycheck, that's salary. Right? So the employee did not invoice the company for every single apple they sold. They don't invoice the company for every single customer that they serve. Right? So there's a different relationship here. But still, it's the same cash flow, possibly. But the meaning of the word money and transaction has changed its context. That's what context mapping is about. We want to figure out how many different meanings there are to certain words. And if I flip this around, what context mapping does is it helps us determine where does the meaning stop, right? So if I have the customer, what defines a context is it defines a boundary where, okay, paying for a purchase, invoicing for a purchase, whatever, like just a normal customer versus business customer, while the shop is open, during normal opening hours at the grocery store, physically on location. There was no remote delivery. There was no online purchase. The meanings of the words being used here, basket, apples, cash, transaction, invoice, payment, they stop. At a certain point, they stop having meaning. They stop having the same meaning. So there are little mini spaces of jargon here. And what context mapping allows us to do is allows us to draw boundaries over how far a certain dialect or a certain language goes. Right, so I can immediately draw another line here, where as far as the business is concerned, I can probably just draw a line over everything money related and create an accounting context. So from the perspective of the accountant, but it doesn't go super far. It doesn't go super deep into the realm of was this using some kind of, was this that user or this user, or was it that cohort from user or this cohort, or was it on a Sunday or was it on a Saturday? They're just money in, money out. There's a certain symmetry to the accounting stuff, and then we need to pay taxes and salaries and try to figure out fees and what's inversed, what's not, etc. How does that impact cash flow? Right, so what context mapping allows us to do, so what bounded context allows us to do in domain-driven design is they allow us to set a boundary on our language. And then what the context mapping allows us to do is that when we have multiple contexts, we can map them. It's like how they relate to each other. So we immediately saw at the beginning that the context of the customer and the context of the employee are not directly related. Like you can even have an automatic checkout where I don't even get in contact with the employee, and the employee still gets paid, and there's no real relationship between my transaction that I'm adding to the system and their paycheck. Maybe there is in some like delayed form that has to go through something else first. But as far as a direct relationship were to be concerned, that doesn't exist. Like in contrast to, let's say, a market where a farmer might be selling their goods directly and they have a direct impact to their salary, how much they sell. They don't have a salary, they just make a profit on what they're selling, right? So they're not even considered being employed in their own farm. They're just a farmer and they go directly, farm to table. So in this I was about to use the word context. In this context, what we're looking for are examples where there are certain domains that relate to each other directly, indirectly. Oh wait, no. I can stay here because wait, do I have it? Yes, I have it. Okay, awesome. I have it. Cool. This is from Vlad Konorov's book that was mentioned in chat. Sorry, YouTube. The links are in the LinkedIn thread. I find it a little bit easier to organize everything if I keep you guys open in another tab, just to avoid all the nitty-gritty of missing your messages. And I'm up to date. Yes, thankfully I'm up to date on all of your comments. Awesome. Any questions so far? If you're still here with me, just give me a live sign that you're here. I appreciate any kind of feedback you might give me live. It makes it that much more fun for me, and I'm sure it makes it a little bit more fun for you as well. Okay, let's focus on this. So what's on the screen right now is what we're going to explore today. So the idea of context mapping is that, as you can see here on, can you see my mouse? Yes, you can see my mouse. So as you can see, there's this kind of relationship. So the arrows have an up and down. There's this kind of relationship. This is an upstream, downstream type of relationship. And most of these upstream, downstream relationships are like that. This one is, let's say, the most tightly coupled collaboration. And there's a third one, which is a dotted line like this, of which we don't have any right now. Have any. What this means is that, in the same way that we use the example of somebody making a purchase and then the employee getting paid a salary and then having to do accounting stuff and supplies. The same way, this context is about, what is this context about? This is some kind of SaaS platform for advertising. They are sending some ad, they're publishing some ads, they're doing some form of marketing. People can log in to manage the CRM. Then there's some billing going on, depending on how the marketing is happening. Then there's some messages being sent to SQS. Ads are being pushed to some external system. I'm assuming that's the ads publisher. And then this is obviously not version 1 of the system, so there's some other legacy system which is doing something very important, very likely. And it's tightly coupled to an older billing system. So you can see that we have two billing systems. We have what I'm assuming is version 1 of the billing system, and perhaps a more automated sort of version 2 of the billing system. Right? So what we want to figure out is there are words being used in these contexts. So somebody who might do a spec for the old billing and the new billing, they might design the tables slightly differently. And the words that they use, for the table name, maybe in one of the systems, a transaction means something very specific. And in another system, a transaction means something completely different. The columns are different. The primary keys might be of a different type or of a different format. The natural keys that are being shared over to marketing, right? Because this is an upstream, downstream dependency. They might be conforming completely depending on how the system is set up. And this allows us to figure out, A, are we duplicating knowledge, right? So this is really helpful with dry. Like, is there a billing system, and is it interpreted more than once? Are they the same kind of billing system? Does one billing system have something else that the other billing system doesn't have? Do we care about this? Is this our primary domain, or is this something completely like a utility? Like, is it just a tool, a library that we use just to be, in business, to capture revenue on the value stream that we provide? The value stream seems to be marketing and ads publishing related. So there's a few more examples here in this cheat sheet, so from the DDD crew. And one of these examples is, I need to open up here, sorry. One of these examples, oh, this is very small. One of these examples is, this is very generic. That's not very, no fun. Let's go back to the basics. So on the idea of context mapping, what we want to figure out is when our teams are building specs and are writing architectures and are setting up the system, maybe they're creating a microservice for every single context. What we want to figure out is who's calling who, essentially. Like, do you know about me? Do I know about you? Do we share a message bus? Do I control the message bus? Do you control the message bus? If you decide to change the structure of the events or the database, do I need to follow you? Do I say screw you? Like, which direction does the change propagation go? That's what we want to map. Because that is by far the biggest, because I'm sure you've worked in a project before. When the context maps were something like this: 1, 2, 3, 4. All of them conformed to all of them, right? And then when it was time to deploy, somebody said, oh, I need to change something. And then everybody goes, oh, hell no. And everybody says, no, you can't change something here because I then need to change this, and then they need to change that, and then that will impact something else here, and then this will mess up that report, and then we have another analytics system outside of this, and then everything will be a huge mess. Right? So that happens when the context map is unknown, and everybody assumes that everybody should conform to everybody else. And if you have microservices that represent contexts where everybody conforms to everybody else, that is the definition of a distributed monolith, right? So that's a big ball of mud plus eventual consistency and complexity, and very hard to deploy, and everything needs to be deployed at the same time, and downtime is a mess because each one of them has maybe 98% downtime, but there's 4 of them, and then there's the load balancer, and each of them have 98% uptime, and then you multiply all of these together, and let me do the napkin math real quick. 0.98 to the power of 5, and you got 90% uptime, and you're down 10% of the time, which sucks, which means you're down for 3 days in a month, which is not cool. So in order to avoid these problems, in order to avoid building a messy big ball of mud in a distributed system with many intercoupled microservices where everybody conforms to everybody else, where the minimum unit of test is, we need to set up test containers with Docker for the entire system on my little MacBook, and then I run a test and it talks to 7 different data. Like, that's the only way to avoid that is to plan not to do that. And the way that how you plan not to do that is with the context map. That's why we're doing this. So if you're wondering, at the beginning I asked you, what is a context map? When do we do it? Why do we do it? We do it when we have more than one context, more than one team, and a team can be as small as 2 developers, more than one team working on something that's mission critical, and they have to collaborate. If they don't have to collaborate, then that's 2 separate projects. I couldn't care less. But when they have to collaborate in order to be successful, like the example that we were looking at earlier, right? So we had billing and marketing and ad publishing, right? So it's all just like the nitty-gritty is all in like maybe one or two contexts, but they all have to collaborate in order for it to make sense. When they have to collaborate, when the dependencies can be unclear, when there's many moving pieces, when maybe one team has to own several contexts, you map their contexts, determine where the boundaries are, so that A, you can figure out what definitely does not go into this microservice. So if you know exactly what goes in here, if you know exactly what goes in here, then you also know what doesn't go in here. So when you try to add a new feature and you know it doesn't fit into any of them, well, then it's time to add a fifth one. That's really important. Because oftentimes what I see developers do is they have 4 microservices and then they have to add a feature and then they don't know where to put it. And the owner of the feature just puts it into the microservice they know the best. And then it has like a little tumor. And then it's just, and then this grows. And then this tumor connects it with something else that this microservice was not connected before. And then again, you can see that you're now spiraling back into the distributed monolith. To avoid all this, the only way to avoid all this is to do context mapping. So, Dennis, how do I do context mapping? Let's explore. So I'm just gonna follow the GitHub because I also forget, and when I forget the context maps, this is the page that I come to refresh my knowledge. So I'll cheat. I recommend that you cheat as well and have this open. So there are 9 different types of relationships, 9 different patterns to the context, and 3 different types of relationships. So the lines, they can come in 3 separate forms. The 2 of them we already looked at. There's the mutually dependent line. Hang on. We had a comment. The reason I stopped, we had a comment that somebody in chat did not see anything on screen. I just joined the stream. Let me catch up. Yes, I do believe it's just you. We have confirmation from Max as well, so I'm afraid it's just you. Try refreshing the page, please. If the screen is frozen, please try refreshing the page. But I have to warn you, I do use an ad blocker on LinkedIn, and sometimes LinkedIn just memory leaks for me. So I just kill the tab and then I refresh and everything works fine. So no, it's okay. Thank you. Okay, glad to know it's working. But please, yeah, if you have any kind of technical problems, I had a 3-hour meeting today where my microphone didn't work and I had constant echo and I was connected with 2 devices. So today, as far as technicalities go, this is not my day. So please let me know if there's anything wrong. We fix it immediately. This is for you primarily. So if you had a bad experience, we can always improve on it. So there's 3 different types of relationships, as you can see here, right? So we have the hard line, we have the upstream downstream type of relationship, and we have the free relationship. The example here is very simple. So a mutually dependent system might be, we're building a prototype, there's a backend team, there's a front-end team, they're working very tightly together, there's a React component, there's a Go API in the backend, and we all collaborate very actively. Like we're not creating the backend API for anything else other than this front-end, and we're just collaborating actively. When we need to add a button, we add it on the API as well. When the API changes, we add it on the front end as well. That's what a mutually dependent context is. And in this case, I now made this sort of backend front-end separation, but it can also be something purely backend, or it can also be purely front-end. You can have micro front-ends, for example, that might be mutually dependent. So for example, you might have a micro front-end for your sidebar menu and a micro front-end for your mainline header menu, but it only shows up on the front page. And those 2 might be mutually dependent because their content has to be synchronized and one has to not show when the other one is present, and they have approximately the same elements, or at least the elements that they share go to the same links, and then two micro front-end teams might be responsible for that. On the backend side, what this looks like is you could have a microservice in the backend, or just a module in a monolith, where one thing is dealing with, you might have a GraphQL thing in front of the whole backend API, and then one of them can be checking posts, the other one can be checking comments, and these might be very different concepts as far as caching is concerned, and then you just have them collaborate. When we change posts, we also change comments. When we change the comments, we also change the posts, and there's sort of like tightly knit cooperation going on. Then there's the upstream downstream. Upstream downstream is your typical I'm using Stripe kind of relationship, where Stripe is your upstream. You are downstream to Stripe. Stripe is upstream to you, and you are basically conforming to their API. Or if you don't want to conform to the API, you can create an anti-corruption layer on your end and flip it around. And then there's the free. This is mostly the free connection is basically two contexts that coexist, and they might be working in parallel, but they might not be exchanging data, or they might be in the same database, or they might actually go to the same data stream, but their interests very rarely overlap. So they might be co-located, they might be cohabiting, they might be in the same VPC, and they just be two separate microservices. They might be triggered from the same pub sub or the fan out, but they don't really care about each other. When one changes, the other one doesn't have to. When B changes, A doesn't have to update. So these are the three types of relationships. Then we have the map patterns. These are the 9 patterns, right? So we have the open host service, OHS. We have the conformist, CF. We have the anti-corruption layer. I think this was the most popular, ACL. We have the shared kernel, SK, partnership, customer-supplier development. Then we have the published language, separate ways, SW, and then the big ball of mud, the anti-pattern that we talked about earlier. Right, so, and then we can also have them on a single page like this. And you probably cannot read this, so I will make it a little bit bigger. There we go. How is it visually? Yeah, this should be good. So the important takeaway on this end is that we need to figure out, when we're doing the context map, what options we have, because you might have several options. With the open host service, we already realized that I can depend on something by treating it as an open host service. So it has this huge complex machinery, and the huge complex machinery is hidden away by some public API. That would be your PayPal, that would be your Stripe. PayPal has like a huge complex machinery about how it works differently with MasterCard and and what is the, I don't know what it's called. The US system has a very specific direct bank transfer, and how it's working with Evercard and debit, and how it's working in Africa, and how it's working with crypto. So it has all that complex system encapsulated, and then it's exposed to you through a service that just says, you are sending something to that customer has some kind of identifier, and you just say amount and currency, and we'll deal with the rest. That would be an open host service. And maybe you are supplying an open host service internally. So you might have an open host service inside your like backend swarm, or like your giant monolith, and the monolith has like a huge open host service internally for your other modules. But you can choose that you won't be an open host, and then your other modules pick and choose what they want to use. It might be a bit more tighter, right? So the coupling might be a bit of lower let's say lower quality, so like more cohesion when appropriate, by being a conformist. In a conformist, the downstream team, so this is the up-down kind of relationship, the conformist is like, okay, whenever the upstream service says jump, the conformist team says how high, right? So you have a direct link. It's like if they break something, this is usually your breaking changes kind of service without any grace period. So if you've ever worked with, I think at the beginning, at the early stages of the Facebook marketing developer program, when you had API access, you had to conform to their API, I think within 3 months, 3 to 6 months. And then they would just shut you down if you're not upgraded. Or they started billing you more, limit your access, right? So that's the sort of more conformist approach. And then they've sort of matured into this open host service where you can sort of pick and choose what you have access to, what permissions you need, etc. And then that also has a published language type of relationship. Then there's the anti-corruption layer. The anti-corruption layer is the other end, is the other extreme of the open host service, anathema to the conformist. An anti-corruption layer, what it does is, yes, we will conform to you, but we, on our side, we will fully abstract away how we communicate with you, so that whenever we change communication with that other thing, our internal communication doesn't have to adapt to that. So everything that comes in from the outside, we are hiding it away by a layer of abstraction. And this is very popular with things like clean architecture and hexagonal architecture, because you can easily say, you know what, I don't really want to be tightly coupled to that. So I want to invert that layer. So it's called an anti-corruption layer because you want to make sure that the corruption from that space doesn't involve your new design, your design of your downstream system, of your where you are working at. And this can also happen, we saw the example earlier. We saw this example earlier. So right, we have a billing system and and two different versions of billing systems. What this also applies to really well is when you have two billing systems and you want to link them up together. So hidden through a facade, you might have an anti-corruption layer for the old system. So the anti-corruption layer is sort of translating the old system into the new system. So to an outside user who might have an open host service, like the CRM in this example, you can see that it has an ACL, anti-corruption layer to the legacy system. So these things, it has an anti-corruption layer to the legacy system and an anti-corruption layer to the ads publisher. So, and this has an open host service to the queue. So I'm assuming that this was direct connection. This is the new one, and then this was the old billing system, and then this is the new one. So it might be that the way it's structured, you might want to say, you know what, I want to have the freedom of redesigning my current next version because we learned something new and we messed something up in the old implementation. We don't want to keep carrying that mistake around. So we will create an adapter for this. And this adapter might be simple. It might just be, okay, translate from A to B, or it might be very complex. It might have a change data capture, like CDC, data streaming. You just lock down the database, hide it away, have delta events going out from the write-ahead log, from the binary log, from MySQL, from Postgres, then go into Debezium with Kafka or Redpanda and have that be streamed into some new system that is the version 2. And then this anti-corruption layer sort of translates from A to B, from version 1 to version 2. That's what an anti-corruption layer would be useful for. Then there's the shared kernel. And I do have to admit, these are a bit hard to understand, even for me. Like sometimes I get them confused, and sometimes there's multiple options, and it's a bit hard to get them into the right space because they start getting a little bit more tactical. They start becoming more dependent on how you deploy. They start being dependent on how you package your modules. They start being dependent on how you organize certain packages, how you organize public interfaces or protocols, or if you're using some kind of protobuf versus SQS, or maybe you're using Kafka queue, or maybe you're using event sourcing, and there's a very specific type of catalog for a group of events. So the shared kernel, number 4, the shared kernel is this is your typical, I'm using, Composer in PHP or Maven or Node.js, and we decide that we will create an SDK internally and we will share that SDK. Like we will have some kind of internal library that everybody is sharing and depending on. So even though I don't know what project A is doing and what project B is doing, we have this shared project and we're all contributing towards the shared project. and then we're just publishing new versions of that shared project, and then each consumer decides which version of it to use, and then there's some rules for deprecation and upgrade rules, etc. You've seen this. This is a very mature way of handling it in large teams, but can quickly get out of hand if you have like 40 different SDKs, and then the SDKs have dependencies on other SDKs, and then you want to install it somewhere, and that's your typical large Node.js, node modules black hole kind of problem, or your typical large Symfony project in PHP, and then it just can't make sense of the 20,000 line composer log file. So that's it. It does have extremes. It does have anti-patterns. Then there's the customer supplier type of relationship. This is your typical, I would say, agency, right? So this is the kind of relationship of bounded contexts where you consult somebody. It's like, hey, we're building this. Would you want this? Or maybe you're offering an open host service, but there's an element where the customer is available for customization, where they might request a feature just for them, which means that the fact that they have requested a feature and they want to incorporate it into their system urges you, so it gives an incentive upstream, right? Because they are your downstream dependency. You are upstream to them. They are influencing you to add something to your system. That's the customer supplier kind of relationship. A very good example of this in like a typical backend system would be security. So maybe you have some kind of main system for identifiable information, for personal identifiable information for users, and you might have a system that tracks that, and then you might have, hey, I have this new PII set. Could you please add this to your set of vaulted secure data? And when we launch, we'd like you to provide that for us and add it in. Or this might be an agency type customer when they say, okay, we are happy with this system, but do you have Salesforce integration? Then you might add Salesforce integration into your system just to make them happy, right? So they have an upstream consequence, an upstream influence on what the team is prioritizing. Then there's the partnership. This is the most typical kind of coupling where a team of two, team of three coordinates with the other three very frequently. This is a very chatty kind of collaboration. So these are usually in the same company, maybe even the same team. Maybe this is a team split into squads. Maybe they're even just changing personnel. Sort of maybe one person is on several teams, and then this is just basically code organization. So it's like diminishing the negative effects of Conway's law. Then you have the published language. The published language, number 7. This is when you have a bounded context. You might have an open host service, but you're not upstream, downstream, but instead you're like peers. Here the example is iCalendar and vCard. So you're communicating about the same thing, but there's a different language to it. Like imagine that you have a Stripe thing and the PayPal thing, and they have to collaborate somehow. It's like, I want to cancel my PayPal subscription and make it a Stripe subscription instead. It's like, okay, do they support that? And like, is that possible? That would be then a published language where you can say, well, I'm doing this thing, so I will publish a language that describes what I'm doing. And then if you follow the same language, you can pick that up and take it over in your own context. A typical example of this would be things like Swagger documentation, Open API, where you can basically define what the server is in a certain language. And then even though the implementation is completely custom, different agents can then talk about, oh yeah, I know this API. Like, you don't have an SDK, I'll just generate one from your Open API spec or from your Swagger spec, or can you give me your Postman Postman dump, and then I'll sort of prototype from there and try to figure backward engineer from there. Because that Postman dump is a published language. The same goes for example, if you're building a TypeScript project and you sort of dump your types and you give it to somebody. These are your typical header files in something like C++ or in the old Objective-C, etc. Then you have separate ways. Separate ways is when you decide that you are coupled, but it's not okay that you're coupled. So it's time to go separate ways. Right? So you might decide that, hey, every time I create a new user, it always needs to synchronize with that email service. I want us to go separate ways. So instead of me calling that email service, I will put something in between that will make my side happy, and then it will allow that other thing to fix itself without my involvement, and then I can sort of move on much faster. This is usually the case when there's sort of like a too tightly coupled like a partnership going on, or a conformist map going on, and one of the teams starts moving much faster than the other one. So they say, you know what, I can't, like, we always have to push and wait for you guys. We're just gonna go separate ways. We're just gonna inverse the dependency. We'll make it, we'll just dump all the requests that we're sending. We're not gonna wait for responses. We're gonna do like an outbox pattern, or have like some kind of inbox for you guys, or a message queue, and then we'll just do our thing. And then if we need some kind of information from you, we'll fix it after the fact. We will have a sort of data stream sort of correcting for the back. This is your typical sort of event sourcing, very rapid fire sort of, okay, there's 10 ideas. One of them was successful, but we're coupled to 4 other things. So you just need to move fast. And then there's the unhappy, the black sheep, the big ball of mud. This is your, basically, either you don't know what's coupled to what, or everything is coupled to everything. And usually it's a mix of these things. So when you want to change something, you might say, oh, like changing anything takes forever because I don't know what to change, or I know it will take forever because I know it will have to change everything else. This is your typical code smell on the architecture levels. You have shotgun surgery, So shotgun surgery is when you want to fix this little thing, and then you have to fix that other thing to fix this thing, and then fix this thing, and then you need to touch that thing, and then you need to update this config, and then you need to, for some reason, redeploy that other third service. That's shotgun surgery, right? When you want to do a little small change, you need to recreate like the entire deployment graph. Yeah, so that's context maps. Now, how does this relate to microservices? If you have any questions, by the way, do let me know. I'm going very fast today on purpose. Okay, there's no questions here. There's the technical difficulties from earlier. All right, cool. How does this relate to microservices? You see, with clean architecture, the context maps help us determine one very important detail. I just need I'm gonna hop over to Uncle Bob's website real quick because I need one of these. Right? So what's happening? Okay, sorry, flashbang alert. What's happening with clean architecture generally is that when you have contexts, and these contexts have a certain relationship, it's usually the domain side. So it's this inside that's coupled with the inside of another system. So it's very rare for infrastructure level systems to be connected by infrastructure. Right? So when we have a context here and another context here, they might be coupled because my domain needs their domain. My entities need their entities. That's usually the case. Now, when you have this is usually the case in OpenHost. This is usually the case in what's the other one? Sorry. This is usually the case in customer supplier. I always forget customer supplier. But this might not necessarily be the case in an anti-corruption layer. Right? In an anti-corruption layer, you might say, I still want to have access to the entities, but I want nothing to do with the infrastructure. Right? So the anti-corruption layer, what the anti-corruption layer does is it says, I want the entities, but this outside layer is a mess. I want that re-implemented. That's why this is important. Because depending on the context map, depending on the type of dependency between the two contexts, on the quality of coupling, on the direction of the coupling, on the type of coupling, on the nature of the dependency of the teams, of how they communicate, how chatty they are with each other, you might want to get away from parts of their system. It's like, I'm okay with the entities, but I don't want to do anything with your infrastructure. Your infrastructure is really slow. I just want the entities, and then I'll have copies of your entities on my own system. Is that okay? It's like, no, we have an auto increment key. You always need to check us for, you always need to ping us and ask us for something, this or that. And then you can say, okay, I want nothing to do with that. I'm going my separate ways. It's in separate ways is the equivalent of I'm setting up a box, and then now instead of talking to the entity, I'm now talking to the box. I want nothing to do with your entity anymore. That's separate ways, for example, right? So that's separate ways. ACL is also very similar, but ACL is on one side, and ACL is usually here. And this says, I want to talk to your entities, but I want your domain layer. And then here on my side, I will implement my own domain layer on the anti-corruption layer. And then I will pretend that this problem has been fixed, and I am now talking to this new domain. Right? So in clean architecture, this is how an anti-corruption layer manifests. It's like I want that domain from over there, but there's a huge mess around it. There's like intercoupled applications, and it's coupled with that other thing that it's incorrect, and the infrastructure layer is an old database. We're going to go to the new database. We're going from on-prem to cloud. And then I create this anti-corruption layer. So from the perspective of the right side diagram, of the right side clean architecture microservice, I am talking to this new domain layer that I am evolving, that I am shaping. I'm shaping it based on seeing what's compatible with the old one, and then removing all the grit that's unnecessary. I'm removing all the tech debt, and I'm sort of remodeling it. And then a new layer will form around this, and then this will at some point receive its own application layer, and then you'll encapsulate it in its own microservice, and then they will split apart. Right? So for you, it's really important to understand if it is in your best interest to start doing this with a modular monolith, how this impacts your project plan. Because such a project plan will need to have a huge emphasis on the new domain, this little tumor, and it needs to consciously separate itself from the old infrastructure, right? So it's this idea of, okay, I will set up a new microservice, and I will force myself not to use your database. That kind of behavior is only appropriate when you're building an anti-corruption layer. If you're building a new feature and it's not an anti-corruption layer, if you're just building a new feature and you're unhappy with how it's built, so while you're building your feature, you're also redesigning them, then it's not appropriate. You should be reading from their database. You should be talking to them a bit more, have a more chatty context map with them. Maybe customer supplier, maybe open host service, maybe start an SDK and sort of go into this published language kind of model. Right, so that's where this comes in. And usually, to finish up, we have 5 more minutes. The microservices can go 2 different ways. And I wish there would be a little bit more emphasis in the books on this. The new talks do capture this. We're going back into dark mode, I'm sorry. This is flashbanging me too much. The new talks by Vlad Kononov and even Eric Evans touch on this, where sometimes the microservices are okay, and each service is their own context. And that's fine. And sometimes that's okay. Sometimes that's a huge problem. Sometimes what you need is you have a big context, and rather than having one large microservice, maybe you should just have several modules inside one context and just cut it quits. Like just be okay with building a monolith and then having multiple modules, because maybe your context is something like this. Like don't default to microservices. Like, analyze your context first. Max has a question. Max, I was curious if the separate ways are ACL working as the role of a facade here. Is this correct? Yes, sort of. But as you saw, the intensity of it is a bit different. So the separate ways, separate ways works in a sort of way of I'll just move on and sort of ignore you. Whereas the anti-corruption layer, there is still chatting going on. So if you look at the diagram between the two maps, the separate ways has a dotted one, whereas the anti-corruption layer has a tightly coupled one. Right? So the anti-corruption layer wants to work together, but it wants to make an improvement on how we're working together. It wants to evolve something that might be considered technical debt. Whereas separate ways says, I'm coupled to something, I don't want to be coupled to it anymore. If I create an anti-corruption layer, I will continue to be coupled to it, and I have to spend money onto upgrading how we're coupled. Separate ways is not that. Separate ways says, there's no facade. I'm just creating like a nullable endpoint, like a dead end for this relationship. So at least my side doesn't crash while we remove you safely. And then I might leave you enough breadcrumbs so you guys can pick up the pieces while we move into a completely different direction. Right? But you can see that in the type of the relationship, like the separate ways is dotted. So there's an interest to no longer be coupled. Whereas with the anti-corruption layer, it is like it's like an open host service. It might be up and down, but we need to improve the quality of the coupling, but we still want to remain coupled. And you would usually sort of once per quarter or once per year, when you're sort of doing an assessment for legacy code or technical debt, you would say, okay, it's time to reevaluate the coupling. Let's shift the teams a bit and let's improve this and that. And we don't need this feature anymore. We will remove this feature and that feature. What would the landscape look like if that was to happen? How do we need to shape the teams so that can happen more safely, faster, maybe even cheaper? Great question. Okay, that's it from my side. We covered context mapping, what contexts even are, why context is important, when in the project you might benefit from doing context mapping, how it relates to microservices, and how it relates to clean architecture. All right, so in clean architecture terms, this is very helpful for a domain-centric architecture where the domain is non-trivial and you have multiple teams working with at least two contexts where there might be issues on how often they need to communicate or how they should communicate, or maybe there's a sort of downstream consequence that if there's too much communication, we will slow us down. If there's too little communication, usually with things like taxes and security, there might be a problem. So we need to set up the relationships to avoid building the big ball of mud. If you don't do context mapping and you have a complex domain, you will definitely 100% create a big ball of mud. The only way to not create a big ball of mud is to do context mapping. Thank you for joining me live. I do have to jump off now. It's book club time. And I'll see you next week. Awesome chat participation. Have a good one. I will send you off with the lovely elevator music. And I'll see you next week. Ciao. And elevator music. Elevator music. Where is it? I never keep it where I want it. There we go.